All right. Good morning, everyone. Welcome to our talk today. Thank you for taking the time to come listen to us on a Friday morning on the last day of REMARS. Hopefully, you guys had some fun at the conference. So for today, we're going to be talking about exploratory data analysis and automated feature engineering for machine learning. I am Isha Dua. I'm a senior solutions architect here at AWS. I've been here for almost 3 years at this point, supporting a variety of different customers across different industry verticals. And my focus areas are machine learning and environmental sustainability. So with me today, I have Shreyas Subramanian. Shreyas, do you want to do a quick intro?
Hey everyone, my name is Shreyas Subramanian. I'm a principal machine learning specialist at AWS. I've been with AWS for about 4 years, and I've helped customers with their machine learning workloads. Currently, I work with autonomous driving customers, which is a great use case. That's way different from what we're talking about today. But once again, thanks. Also, thanks for folks coming in now on a Friday morning. We'll try to keep this as interesting as possible.
All right. Thank you for that, Shreyas. So with that, just a couple of pointers here. So this is a 300-level talk. So we do expect you to be familiar with some of the foundational concepts around exploratory data analysis and feature engineering. It's great if you've played around in the Sagemaker ecosystem, but if you have not, that's OK. Don't worry about it. I'm going to take the first few slides to actually introduce some basics about the process. So with that, let's look at the agenda. All right, so like I said, we're going to start off with a couple basics. We're going to talk about what exploratory data analysis is, what is feature engineering, how have customers been doing this so far, what are some of the challenges that they have pointed out to us. After that, we're going to pivot to EDA and feature engineering in the context of Sagemaker Data Wrangler, which is our low-code visual tool for data preparation. And we're going to talk about Data Wrangler in a lot of depth for this session today. Then we're going to actually look at a demo, which is going to be doing data preparation of time series data within Data Wrangler. And we're going to follow that up with a short Q&A. So just to level set some expectations here, again, 300-level talk. And if you do have any questions during the talk, please hold on to them and towards the end. And you can come stay over, talk to us about it later. So with that, let's jump right in. So according to a recent survey that was conducted by Anaconda, it stated that data scientists and ML practitioners are spending a good chunk of their time doing tasks like data loading and cleansing and visualization, pre-processing. And they've mentioned that to do these different tasks, sometimes it requires different tools, different technologies, and it's not very easy to stitch them together. And those tools and technologies may not be resource-friendly or DevOps-friendly. Another thing data scientists have pointed out to us is that they're pretty oversubscribed, actually. Machine learning use cases are ever increasing. They would love it if other stakeholders within the organization can contribute to the development of the machine learning models that you're building out. So what do we want to do? We want to help you scale your machine learning initiatives. And we want to make sure that all the different stakeholders within your organization are able to collaborate faster, to experiment faster, and help productionalize your models in a much faster manner. So what is exploratory data analysis? So as the word suggests, exploratory, it's often going to be the very first step that you're going to do when you start with your data set. It's going to be a combination of loading and aggregating and joining data sets and visualizing, pre-processing, data wrangling, all of that. And as you can see, visualization is also one of the very important steps of EDA because you want to make sure that your data is actually representative of the underlying problem that you're trying to solve. So what are the different kinds of questions EDA would answer for you? Or what are you looking for? So for EDA, you're trying to understand the defining traits and the differentiating characteristics of your data set beyond the formal modeling and the hypothesis testing tasks that you're going to do. And you would have questions like, what kind of data is it? Is it columnar? Is it tabular data? Is it time series data? How complex is the data? Are there multiple files within the data set? Do these files need to be joined with one another? Are they nested? So you would also look at the complexity. You would also try to understand, is this data enough for building my machine learning model, or do I need more? You would actually look at the different columns and features within your data set, and you would try to understand, are they independent, or do they have some sort of a relationship with each other? Are they correlated? Do they have a relationship to the target that you're trying to predict? So all of that's exploratory data analysis. And one of the very key steps within EDA would be data pre-processing. And data pre-processing would be, like, for example, you have HTML tags in your data set. You may want to remove them. You have missing values or null values that you may want to impute. You may have, let's say, abbreviations that you may want to replace. So these are some of the different data wrangling steps that are also included as a part of the EDA process. So once you're done with EDA, the next step that you're going to do is feature engineering. Feature engineering is something that I would say requires a little more domain knowledge or subject matter expertise. It's the process where you're going to use statistical methods to transform your raw features into something that's better understandable by the underlying machine learning algorithm, or it's better representing the business problem or the machine learning problem that you're trying to solve. Examples of feature engineering would be, let's say, there is a particular column. Sometimes taking the mean, median, or percentile of the data actually results in better model accuracy. Sometimes, you want to maybe encode your categorical variables. Or you maybe want to look into balancing your data sets. So all of this goes within feature engineering. So how have customers been doing it so far? How is this usually done? So customers have told us that they've used desktop-based tools for this, desktop-based tools like Excel and Tableau Desktop. They've also told us that some of their teams write custom scripts. So they may write scripts in R, they may use Python or Perl or whatever their scripting language of choice is. And finally, you could also use SaaS-based solutions like Trifecta or Tableau Cloud or H2O AI. But what are some of the pain points that come with these methods, and what have customers told us that they are struggling with? So with desktop-based tools, they mentioned to us that it works okay. It's good for smaller data sets, but if the data set exceeds a certain size, they tend to become slower. With scripts, for example, let's say there are different teams writing different sets of scripts. It gets very difficult to create and maintain these repositories. Sometimes it may lead to duplication of effort. There may be different teams engineering the same set of features, and that becomes very difficult to maintain in the long run. And finally, for SaaS solutions, they mention that they just don't want to be logged in, and they don't want to use a proprietary solution. And they don't want to be paying for the punitive licensing terms, either for the SaaS solutions or for the desktop-based solutions. So what do we want to talk about today? So I want to talk to you about some of the AWS offerings in the low-code, no-code space for machine learning. So let's start with Sagemaker Canvas. Sagemaker Canvas is our visual point-and-click UI-based tool that lets you do model building, training, predictions, all without writing a single line of code. Now, who are we targeting here? Who does it help? It helps your business teams, and there may be business analysts and business intelligence teams that may not want to write code. They will have the domain knowledge, they'll have the subject matter expertise, but they may not have a machine learning background, so they may not know how to apply that domain knowledge to your machine learning model development process, right? So that's where Canvas is really going to shine. And for the low-code tools, you see there are 3 on the screen. So we have Sagemaker Data Wrangler, which I mentioned that we'll be talking about in a lot of detail today. That's going to be our low-code, visual, point-and-click, UI-based data preparation tool. We also have Sagemaker Autopilot, which is our auto ML capability. And what it does, it runs this series of experiments for you. It selects a certain set of features. It's going to select a particular machine learning algorithm. It's going to maybe take certain values for your hyperparameters. So it does all of that. It does feature engineering, hyperparameter tuning, training, and it runs through these series of experiments, and then it generates a list of, it ranks the models that it has generated running those experiments. And those models can be, you can look at those models and you can look at the accuracies of those models. So once you do see, when you do see a model that has the highest accuracy, you can actually dive deeper into that model, double click on it, and look at the features that were engineered in the process, or look at the hyperparameter values that were chosen by Autopilot. So again, Autopilot is a low-code auto ML tool that's going to give you a great starting off point if you do not know what sets of experiments to run. So it's a great kickoff. I would definitely recommend that you try using Autopilot. And finally, I want to talk about Sagemaker Jumpstart, which is it's like a library of solutions and models. It's our pre-built solutions and models that we have built out for you that span different industry verticals, different kinds of use cases. You can actually build natural language processing, computer vision, and more different use cases with Jumpstart. One great example would be, let's say you do have a manufacturing unit, and you're getting all of this data from the manufacturing unit. You want to run some predictive maintenance against that data. So that is an inbuilt solution within Sagemaker Jumpstart. So you can actually leverage that. These solutions are very easily tunable as well. So you can tweak certain things that you want to change and see how it performs with your data sets. And you can actually, again, get a very good start-off point if you do not know where to start, if you do not know which algorithm to choose. And these are solutions that can really help you. So why even do low-code? So it is going to help you derive insights from data in minutes. One very key important factor is the fact that all of the different stakeholders in your organization, including the business analysts, the business intelligence teams, they're going to be able to collaborate on the process of machine learning model development. You're going to be able to experiment faster. You're going to get insights in a couple of minutes, and you can thereby increase the release velocity, or basically get your models to market faster. So that's why low-code will actually help. So this is where I want to start talking about Sagemaker Data Wrangler. Sagemaker Data Wrangler is our low-code, visual, UI-based point-and-click tool that lets you do data preparation, feature engineering, and it lets you do data enrichment, pre-processing, all of that within one ecosystem. So there are a couple of features. All of these features we're going to talk about in a little more detail as we progress along this. But just to sort of give you an overview, you can connect to multiple data sources, and we're constantly adding more data sources to Data Wrangler based on what our customers are telling us. You have the ability to import in your entire data set, or you can actually choose a sample of your data set as well. You can use, there are like 300 plus built-in transformations within Data Wrangler that you can leverage. These are both non-machine learning and machine learning-based transformations, and we'll talk about them as well. There's this whole rich library of plotting and charts that you can use, so you can easily do your visualizations within Data Wrangler. You can build these data transformation flows within Data Wrangler, and you have the ability to export these flows to either S3 or Feature Store or SageMaker pipelines, for example. You can even export it as a Python script and then take that script and inject it into your CI/CD pipeline. So it gives you this sense of repeatability without configuration drift, right? So that's something that Data Wrangler would be able to do. One of our customers, they're named Equilibrium Point IoT. They mentioned that they were able to save 50% of their time doing data preparation with Data Wrangler instead of using whatever they were using within their system earlier. So again, I would recommend that definitely look into Data Wrangler. But before we do that, let's dive a little deeper into these individual areas. So data sources, like I said, Data Wrangler, one of our key differentiating factors here is that we have a wide variety of data sources. You can connect to S3, Athena, Redshift. We've also added Databricks, Delta Lake. We've added Snowflake. We're constantly adding more. Customers have told us that they want to have the ability to bring their own JDBC connectors and to be able to connect to their SaaS applications. So that's also going to be something that Data Wrangler is going to support. An example, let's think of an example where a customer wants to build some sort of a forecasting model using the data, the leads data that they have in Salesforce. So that's something that they'll be able to bring into Data Wrangler as well. You also see that there is support for multiple file formats. So we do support CSV, Parquet. We recently launched JSON and ORC. We have support for Athena database tables as well. So like I said, there are a variety of data sources that you can leverage here within Data Wrangler and start importing your data sets in. So you do have these data sources, you're importing the data sets in. Now, you also have the ability to visually browse these data sets. You have the ability to import the data set, look at the preview of the data set. So as you can see on the screen, you'll actually see a table pop up, which is the preview of the data set. Data Wrangler automatically identifies what data types, what are the data types for your different columns. And yes, you do have the ability to change those data types as well. But it does auto-detect the data types. It shows you what the data set looks like. One key thing here would be, like I mentioned earlier, you have the ability to import the entire data set, or you can tell Data Wrangler to, let's say, import only a randomized sample of the data set. Or you can tell Data Wrangler that import like the first k rows of my data set, where k is an integer that you're going to define. So yeah, it's a great feature. You can visually browse that data set. You can preview it. We do have support for, as you can see, VPC, KMS. Let's say you do have a data source where your data is encrypted. You can use your keys to decrypt the data once that data gets into Data Wrangler. You also have the ability to encrypt the data, encrypt the output of the Data Wrangler flow before you push it out to S3. So again, definitely look into your data sources. One very key integration I would want to point out, again on the same theme of previewing your data set, is our integration with Athena. So Athena is our interactive querying tool, which is, think of it, it's comparable to like a SQL Explorer. So you'd be able to write your SQL queries against the data that lives in S3. So you can write your Athena queries, you can preview the data set, you can generate an output from the Athena queries. That output of the Athena queries can also be imported into Data Wrangler. All you need is an Athena database to exist. And we do have support for Athena workgroups. You can send out the output to custom S3 buckets as well. So again, it's a great tool if you want to sort of look into your data set, preview the data set before you import it into Data Wrangler. So now you've imported your data set, you've loaded it in, you've previewed it, you've looked at the data set. What are you going to do next? You're going to visualize it. Again, for all of the ML practitioners, visualization is very important. Visualization is key because it lets you understand that your data set, whether your data set is representative of the real world or not, whether it is representative of the problem that I'm trying to solve or not. So again, there are a lot of built-in transformation. There are pre-configured visualization templates that you can use. You can plot your histograms. You can look at data distributions. You have the ability to do box plots, whisker plots, scatter charts, all of that. And if you want to understand the data distributions, the relationships, the compositions, the correlations, this is a great way to start. So you'll get very quick insights with the visualization templates that we have in Data Wrangler. And not just simple visualizations, but also some advanced visualizations. And that's something that you can really leverage because these advanced visualizations are going to let you diagnose some common issues that happen in machine learning environments, like target leakage or multicollinearity. An example that you see here on the screen is that of a target leakage. So in this example, we're trying to predict the arrival delay of the flight. A target leakage is a scenario where you have trained the model with features that may not exist at the time of the prediction. So in this case, you see that arrival delay has a prediction score of 1, which is absolutely an error because it's probably the duplicate of the target column that you're trying to predict. Any score that's less than 1, Data Wrangler is still going to tell you. So it would be great if you review that with your domain experts, look at the features that you want to drop or look at whether that is relevant, whether that's a target leakage that you want to sort of remediate or not remediate. So all of that's great. We looked into the visualization of the data set. We used these pre-configured templates to draw out our charts and plots and everything. Now we want to start transforming the data. Now we want to start managing some of the data. We want to start doing some data pre-processing. We want to fix our null values, our missing values. So again, there are so many transformations. There are 300 plus transformations within Data Wrangler. Some of these you can see here. You have the ability to manage columns, rename them, drop them. You have the ability to balance data. You can encode your categorical variables. You have time series transforms that we're going to look into in the demo as well. You can process your numeric data. You can do a lot here. So again, a bunch of built-in transforms that it's just a simple click of a button, and you'd be able to apply those to your data sets. As I had mentioned earlier, there are machine learning specific transformations and non-machine learning specific transformations as well. So some of the ML specific transformations would be these that you see on the screen and more. These are only a subset of what I could show you. But one-hot encoding, for example, you want to encode your categorical variables because there are some machine learning algorithms that perform better with numeric data. So doing the one-hot encoding process may actually improve the model accuracy. So this is one of the very common transformation that many of our customers use. You can also balance your data sets or balance your data, whatever techniques you want to use. You want to use random oversampling, undersampling, SMOT, whatever. You have the ability to do all of that just from drop-downs, from point-and-click UI-based tooling. And you also have the ability to look into time series transforms. This is a very key feature I wanted to point out. Again, I would definitely recommend that look into the data insights report. It's what we call the data insights report or the data quality and insights report. It is something we recommend that you do right after you import your data set. So do this as the first step after you've imported your data set into Data Wrangler. So what it's going to do is it's going to produce this report for you, these ML-powered insights, just with a click of a button. And it's going to give you a lot of information. It's going to show you the distribution of the data. It's going to tell you missing values, outliers. It's going to give you some statistical information. So definitely, if you do not know where to start, what kind of transformations to do, run through the report, and it's going to tell you. It's going to give you some defining, it's going to give you some characteristics of your data set. And it also gives you some alerts about certain issues that might be, that it might see in your data set. So it might alert you for something like a target leakage that we were talking about earlier. It can look into anomalous records or duplicate rows in your data set, and it can give you those alerts as well. And it won't just give you the alerts, but it'll also give you some recommendations, like, to fix the problem that it's seeing. So it'll tell you that, OK, do these transformations to fix this problem that I just diagnosed. So you'll get some actionable insights from the data quality and insights report. So I would, like I said, definitely recommend that try out the data insights report within Data Wrangler. It's a great feature. Now, let's say you ran through all of that, and none of those transformations that are inbuilt into Data Wrangler work for you. You want to write something custom. So in that case, we do also provide support for custom transformations. Using your flavor of choice, you can either write your custom transform in PySpark, in SQL, in Pandas. So you have the ability to do custom transformations as well. Now, with that, I'm going to hand it over to Shreyas, and Shreyas is going to talk about some of the time series data transforms that exist within Data Wrangler, as well as the Data Wrangler flow and how to export that. Go for it. Thank you.
Thank you, Isha. So far, we've been talking about Data Wrangler in general. We'll talk about why time series data has to be handled in a special way. Just really high level, a tabular data set may not be a time series data set. Tabular data sets are, maybe a representation of one time, snapshot of time. Whereas time series data, which I'm sure a lot of you already have experience with, it involves a timestamp column, and it has multiple other columns generally. and the timestamps are generally in increasing order, and you have all of the other values as well changing in any order of fashion. So what makes this special and in terms of transformation steps is that the built-in transforms and transforms that you have to really carefully look at are different for tabular data and time series data. I'll give you a really simple example, right? So if you have missing values in your regular tabular data, it's easy to take the same category of data or the same class of subset of data and kind of average it or fill it in with zeros or fill it in or drop out those rows. With time series data, you might have to interpolate between two available timestamps. So many of these things like resampling to a different frequency, so you have maybe day frequency data and you want to make that into hour frequency data, using lag features. Lag features generally are, you have features of the same column from a previous timestamp that are usually useful for autocorrelation and predicting future values. And then rolling window features are, imagine there's a rolling window of time and you're averaging or calculating some other statistics of the time series. And then you can also featureize the date time, which is something that we usually do. We take the date time column and we want to extract the quarter, the year, the day, month, and then use that specifically for our machine learning tasks downstream. So all of that is something that you can do with Data Wrangler. It's all built-in transforms. You can very easily pre-process and manipulate these time series data with, again, like what Isha said, you go down to the selected transform through a drop-down, select some options relevant to that transform, and then add that step to your visual workflow. This includes some really advanced transforms like trend detection, decomposition of your time series data set, as well as Fourier transforms and calculating Fourier coefficients. And all of that you can do without code, which is great. So here's an interesting slide with seasonal trend decomposition. On the top left there, you have the original signal. Imagine it's coming in from sensor data, really noisy sensor data. You can't really use this signal as is. And so seasonal trend decomposition using this technique called lows, and that's why there's an L at the end, the STL. So what that technique does is it splits the original signal, which is a really noisy signal, into three components. So you have the trend on the top right, which is kind of the average flow of the data. You have the season, which is the frequency of the data, so how periodic it is. And then finally you have the residual, which is kind of the error. So the idea is if you add up these three signals, so the trend, season, and residual, you'll get back something very close to the original signal. And you can drop out, let's say you don't want the residual, you just want to focus on the trend. That's a great way to take features from your time series data set. Again, this is something that's built in as a feature within Data Wrangler. Now, generally with tabular data as well, we don't really think of machine learning modeling, but one great feature within Data Wrangler is that you can do a quick model. This quick model, what it does under the hood is it takes PySpark's ML library and either fits a regression or classification model, and that takes a couple of minutes depending on your data size, right? And what that gives you is one, do your features have predictive power to predict your column of your target column? And the second thing is that it'll also give you some feature importance scores. So what you see on the screen up here is feature importance scores for a particular target across all of the variables, and that's another great signal back in your data preparation steps where you can sit and drop out some of those columns that don't have any importance in predicting your target column. So this is an example. If you've not seen Data Wrangler earlier, this is an example of what a visual workflow looks like. What's happening here is you see two streams of workflows. You have starting from two sources of data. Both of those are CSV files in this case. One goes through and gets transformed with a SQL step. Another one goes through and gets transformed with several visual steps. And then finally, you want to join that data. Right? So what's great with Data Wrangler is you can build arbitrarily complex data flows. And those flows are, Data Wrangler is a white box solution, which means you actually know what those steps are. You can edit those steps, and the code underlying those transformations is available to you as well. And what you can do is, once you have that code, you can either edit the code directly or you can open it up in the Data Wrangler editor. And you can add steps, delete steps, modify it. You can version your flow files, which is another great feature. And then finally, Data Wrangler records all of this, and you can then export your data, as we'll show in the next slide. So once you have your flow, it's a really easy step to go forward and hit export to S3, which is our simple storage service. So you can hit export, and that CSV or any format data will get saved to Amazon S3, and you can then use that for your downstream machine learning processing tasks. One great thing I think Isha already mentioned is that you can either use a sample of your data set, the first K rows, or some representative sample of your entire larger data set. You do your transforms generally with a smaller data set. You want to make sure that the transforms work out, and you want to apply it to a much larger data set, right, with the same schema generally. So that's something that you can do with Sagemaker. You can also export to something called a feature store. You might have caught some other sessions mentioning feature store, but this is where you can share common features that might lead to multiple ML use cases. So that's a great way to save some time, because multiple teams might be creating the same features again and again. And then finally, apart from S3, which we talked about, you can export your data to, you can also use Sagemaker pipelines, which is our MLOps pipelining tool for not just doing data preparation, but building, training, tuning, and deploying your models in some particular DAG or acyclic graph. And then you can also export your data to S3, like we said, and then to feature store. And with feature store, you can also reuse those features. So those are considered really high quality features, and those high quality features can be used for multiple use cases. So Sagemaker Data Wrangler is available wherever you can find Sagemaker Studio. So the way to access Sagemaker Data Wrangler is within Sagemaker Studio. So that could be a very important consideration. And it's also priced per instance usage. So you pay as you go, and you only pay for what you use. If you're not using Data Wrangler, you don't pay for anything. Your flow files and your actual data preparation steps are still saved, and you don't really pay for that storage. The one last thing I'd like to mention is Data Wrangler also has an underlying instance where these calculations are taking place, and those instances are also adjustable, right? So if you think your transformations require more memory or more compute power, you can actually switch out those instances and continue your processing. So with that, I'd like to switch over to a demo of a use case I think you guys will find interesting. Let me see if that comes up. All right, great. So when you start off with Data Wrangler, this is kind of the screen that you'll see. Like we saw earlier with Isha's slides, you can import from S3 or Athena or Snowflake or Databricks. What we're going to do here is import some Bitcoin data. It's recent data from March, but we all know from March to now it's actually have dipped down quite a bit. So if you look here at the data set, you see a timestamp column. You see, maybe you can't see it very clearly, but a Unix timestamp column, a regular date timestamp column, and what you would see in regular trading scenarios, the open, high, low, close values of the particular signal, which in this case is the Bitcoin to USD. So those of you who notice this is, it's ranging at about $40,000. That was in March. Right now, it's actually $20,000 a pop. But if you follow this use case through enough, you'll get interested in high frequency trading and algorithmic trading, and maybe you can get back some of the money you lost at the casinos downstairs. So that's our data set. What we're kind of trying to do here is feature engineer your time series data. In this case, it's Bitcoin signals from around March. And this is per second data. And within each second, you have open, high, low, close value, and those are the 4 columns. You also have the volume, like any other trading signal. And finally, you want to prepare your data in such a way that you can take 1 second of data, featureize that, extract as much information as you can from the open, high, low values, and then try to predict the close values. And that's the use case we're going to follow. We're not going to actually build a model, but we'll talk about just the feature engineering steps here. So that's our data sets, a simple CSV file with more or less clean data in this case, but we'll show you some ways to validate whether the data is clean. The first thing that you see here is that big plus button. Every transform, every step, you want to hit that big plus button and select your transforms. In this case, generally with Data Wrangler, you want to select the right data types for each column. Now, Data Wrangler will automatically select what it thinks is the right data type. So in this case, Unix timestamp was selected as long, which is the right one, so we'll switch that back. The date time column is already automatically selected. And we have some duplicate information here, right? So you may not want to use the Unix timestamp and the date time column. So you can pretty much drop one of those. So we're going to drop the Unix timestamp column and the symbol column because it's the same. We're only dealing with Bitcoin data. There's no different symbols. So this transform step is pretty much drop. If you're aware of SQL, it corresponds to the drop command in SQL. So every step that we add, we want to preview it, see if it's going okay, and then add the actual step to the workflow. So we'll do the same thing again, hit the big orange add step button, and then search for any transform in the search box. In this case, we're going to do some custom code. Isha mentioned this earlier, so you can use Pandas, PySpark, and SQL code, or even plain old Python code. And in this case, we're going to actually group multiple columns into one column. So this is a process called vectorization. It's very useful for feature engineering later. So in this case, we're creating like a temporary column called V, which we'll drop later on. But this V column actually holds the open high and low values. So we're going to group those all into one column by writing this command, right? So df, if you're wondering what that is Pandas code. You don't have to use Pandas code. You can use SQL code if you're a SQL pro. But in this case, we're creating a new column called V, and we're going to drop that column later. It's a temporary column. We'll group together the open, high, low values, and we'll create that as an array within one column. And you'll see why that's required. So once you write that code, you can take a look at other options here. This one's written in Pandas. Some libraries are already installed, like PySpark and SQL and plain old Python. If you like that, you can create your own class, your own function to do any transformations. So right now, we'll just stick with Pandas. We'll again preview the step. So the preview will give us what the column is going to look like in a couple of seconds. And then once that comes through, you can go through the column, see if, so you'll see a new column called V at the end of the table with multiple values in it. And then we can, now that we have the open, high, low values in a particular column, we can drop those other columns that we've actually put inside the temporary column. So in this case, we're going to, again, go back to drop column and drop the open, high, low values. In this use case, in this fictitious use case, we're imagining we're not going to use the volume data, but it's actually very useful data. So if you're actually doing this and following through this use case, consider not dropping those. So as you can see, we're successively adding steps. We have about 5 steps and 4 more steps to go. The next one we'll do is very relevant to our talk here. It's time series specific steps. So one we're going to do here is called extract features. Extract features from that V temporary column that we had. We use a library called tsfresh, and you might be aware of this already. tsfresh is a time series data feature engineering library. In this case, as you can see, we've generated a bunch of derived columns. So you see from that set of 3 values, open, high, low values, we have generated the sum of values, median, mean, standard deviation, variance, and about 8 features, right? And that happens really quickly. With tsfresh, you can actually generate up to 800 features from that one column. And usually, for AutoML tools, you want to generate as many features as you want, and you want the AutoML tool to down select from those features. In this case, we just demoed like a minimal subset, and that's the drop-down that you see there. But you can go up to 800 features, and that means 800 new columns per column that you're featurizing. So you'll see that there's some columns there, so mean, median, standard deviation, and also length of the vector. So the interesting thing there is we had only open, high, low values, so the length of the vector is going to be the same. So we'll drop some more columns that we don't think are useful for predicting, right? So if you have the same value across all rows in your time series data set, it's most likely, it's definitely not going to have any predictive power to your target variable. So we'll drop the length, we'll drop the sum of values, which we think is not relevant to this particular use case. We'll keep all of the other ones and drop the original temporary value as well. And as you can see, we're successively adding steps. You can go back and modify it, but be careful with that because it's going to affect the downstream steps as well. One of the last things that you want to do is with time series data, a lot of the timestamps may not be formatted correctly, and so there's a nice validate timestamp step here. So we could go down and say, here's the policy you want to follow. If you find a wrong, funny-looking timestamp, you want to drop that entire row. So that's what happened right here. You can choose that option, again, preview it, and then add a step. So we see like 8 steps right now, starting from the S3 source. We grouped the data, we dropped some columns, and finally we validated the timestamp. And right before we give it off to our data scientists, we can even scale the data. So right now, as you know, in this case, this is March data. It's 40,000 or so for USD to Bitcoin to USD. You can actually scale that and normalize it across a center across each column, and that usually helps because you want your model to be kind of scale invariant. And so that's something that's done here, where you can define some options, and you can see once we preview it, all of your values will be from -1 to +1, or center around a mean of that entire column. So this looks great. So your timestamps are validated. You have derived much more features than you had earlier. You've dropped some unnecessary columns, and now you have a data set where you can take timestamps and predict the close value, for example. So what we'll do as next step is export this data. We're not going to actually export the data, but here's what Isha talked about earlier. You can export directly to S3, and that's a really convenient step. A couple of other things that you can do with time series insights. We talked about general insights of tabular data. One really important insight that you can derive from time series data is anomalous values, right? So you have an anomaly detection algorithm that you can run a report on, and gives you back a nice visualization. So it's a great tool to use end-to-end, and just be mindful that this is within Studio. So if you want to use Data Wrangler, you want to log into Sagemaker Studio and then use it with your data sets, whether that's S3 or Snowflake or Databricks or even JDBC connection to your actual tabular data. With that, I'd like to call back Isha up here. I will do some closing slides, and we'll be happy to take any questions after that.
So actually, just one closing slide. I just wanted to point out that if you want to dive deeper into Data Wrangler, we do have, please definitely look at our product page as well as the documentation. There are a bunch of workshops out there. There's the time series demo that you just saw. It's based off of a blog as well that you can look into. So if you want to recreate the time series demo, you have the ability to go into the blog, try and recreate those steps. So definitely look at those. If you want to sort of get some training around Data Wrangler, again, you could contact your account team. You could go through immersion days. You could also go through some of our workshops that we've built out. These workshops some of them are industry focused. Some of them are also cross-industry. So we do have Data Wrangler that we are showing in, I think, for financial services and healthcare and life sciences. So if you're interested in those options, definitely, I would definitely recommend looking into the workshops that we provide. With that, I think that's pretty much it. Thank you so much, everyone, for taking the time to come hear us talk about EDA and feature engineering early in the morning. Hopefully, you got something out of this session. And if you have any questions, if you want to have a chat with us, please feel free to stay over. Thank you again.
Thank you.